Hello guys, I'm NESTOR Sayson Jr., BSc student in PSUB. This tutorial video is a Python program that will implement a list data structures using linked lists. So let's start. The program should display the menu below. We use Tony compiler to compile and run the program. First, create a function to display the menu. Then print the menu. Call the menu function to display the menu. Then create a function to enter the program. This is the start of program for linked list creation. First, define class node. Class node with two variables, data and self. Then create a initialization method. Then assign data and initialize next as null. Create a class-defined linked list. Function to initialize the linked list object. First, initialize the tail with none. Then initialize the head with none and initialize the count with 0. Create a function to add node at the beginning with two variables self and new data. Allocate the new node and assign data element. Change next node of new node as head. Change the new node to self.head. Then create a function to add new node at the end with two variables self and new data. Allocate the node and assign data element assign null to the next of new node. Create the linked list if it is empty or not. Then if empty, make the new node as head. Else traverse to the last node. Change the next of last node to new node. Next, create a function to insert new node to certain position with three variables, self, data, and position. Allocate node to new element or new node. Check if position is greater than to 0. If position is less than to 1, then print position should be greater than or equal to 1. Else, if the position is equal to 1, make next of the new node as head and new node as head. Else, make a temp node and traverse to the node previous the position. If the previous node is not null, then make new node next. .next as temp.next and temp.next is now the new node. Else, when the previous node is null, print the previous node is null. Next, create a function to remove the node at the beginning with variable self. Allocate the head as the node. Then allocate the next node as the self.head. Assign the next node as null or none. Next, create a function to remove the node at the end with variable self. Change previous node as head of the node, head node. Then allocate the next to head node as node. Create a loop that will check if node is null. Assign the previous node as none or null. Next, create a function to remove the node at certain position with two variables self and position. If linked list is empty, then return store head node to temp. If head needs to remove, then temp is equal to none. Find previous node of the node to be deleted. The position will start at 1. Then, if temp is none, it will break the program. It will break the loop. If position is more than number of nodes, then return node temp.next is the node to be deleted, then store pointer to the next of node to be deleted. Unlink the node from linked list. Next, create a function to remove node with two variables self and remove node. Store head node to temp. If head node is self holds the key to be deleted, then remove at the head. Search for the key to be deleted. Keep track of the previous node as we need to change. Rev.next. Remove until value is found. Then if data or temp.data is equal to remove node, then number or n has been successfully deleted. If remove element not found, then print n or number is not on the list and cannot be deleted. Next, create a function to search number. Create a temp node pointing to head node. Create two variables, found to track search and I to track current index. If the temp node is not null, then check the node value with search value. If found, update variables and break the one. If found is equal to 1, then print the data is found at position of the data. Else, it will print data is not found in the list. Or else the list is empty. Next, create a function to display the number at certain position. Initialize temp to self head. Initialize temp as self.head. Then index count is equal to 1 is the index of current node. Loop while end of linked list is not reached. If count is greater than 5, then it will print invalid position. Return to 0. Next, create a function to print all the numbers on the list. If self.head is none, then it will print empty linked list. Else, if temp is equal to head or self.head, it will print the data, arrow, and null or none. That's it.
Hi guys, I am JOMAR P. DAMOT and I will explain the input option of the program. This line is the initialization of option to enter the choice. If the user choose option 0, the user will be asked to confirm exit to the program. If yes, the program ends with an ending message, "Thank you." Else, if no, menu display again to continue. Else, if the user input wrong input, it will display the invalid input and the user will be asked again to confirm exit to the program. If the user choose option 1, it will display you enter insert at start. Then it will print the list. The user should enter the value of the number to be inserted. Then this line is the creating node elements. Then this line call the function at the beginning. Then display the list. For insert choice 2, it will display you enter insert at end. Then it will print the list. The user should enter the value of the number to be inserted. Then this is the creating node elements. Then this line call the function at the end. Then display the list. For option 3, it will display you enter insert at position. Then it will print the list. The user will enter number at the position where the number is to be inserted. Then this line is the creating node elements. Then it will call the function insert position. Then it will display the list. For delete, for option 4, it will display you enter delete at start. Then it will print the list. Then this is the creating node elements. Then it will call the function that deletes the value at the start. Then it will display the list. For option number 5, it will display you enter delete at end. Then it will display again the list. Then it is the creating node elements. It called the function that deletes the value at the end. Then display the list. For choice 6, it will display you enter delete at position. Then it will print the list. The user will enter the position where the number is to be deleted. Then it is where we create the node elements. Then this line call the function delete position. Then display the list. If the user choose option 7, it will display you enter delete number and then print the list. The user will be asked to enter the value of the number to be deleted. Then this is where we create the node elements. Then it is the call function remove node. Then display the list. For option 8, it will display you enter search number. Then it will print the list. The user is asked to enter the value of the number to be searched. Then is where we create the node elements. It is the call function search number for choice 9. It will display you enter display number at position, and then it will print the list. Then the user will enter the position of the number to be displayed. Then it is the line where we create the node elements. Then it is the call function display at position. For choice 10, it will display the list. It will display you enter display list up, then it is the line where we create the node elements. Then call the function that prints all the numbers on the list, else it will print invalid input. Then this is the enter function, and call it.
Hello guys, I'm JOHNLERY MIRANDILLA. I will demonstrate and run the program. So let's start. If the user choose option 0, yes or no will only be accepted to run the program. If the user enter no, the menu will display again. And if the user entered yes, the program will end and display the word thank you. For option 1, the user will be asked to input a certain number to be inserted at the start of the list. For example, we enter number 11. The program will display a new list where 11 is inserted at the start of the list. For option 2, the user will be asked to input a certain number to be inserted at the end of the list. For example, 55. The number 55 is inserted at the end of the list. For option 3, the user will be asked to enter a number to be inserted at the list and the position he wanted to put the number. For example, 12. And we want to insert it at position 2. 12 is inserted at the position 2. For option 4, the user will delete the first number in the list. For option 5, the user will delete the number at the end of the list. For option 6, The user will be asked to enter a position range from 1 to 5 and that number will be deleted. For example, we enter a position 3. Position 3 is deleted, or the 30. For option 7, the user will be asked to choose a number from the list that he wanted to delete. For example, we want to delete number 20 from the list. Number 20 has been deleted successfully. For option 8, the user is asked to enter the value of the number to be searched and the program will display its position. For example, we want to search the number 30. Number 30 is found at position 3. For the option 9, the user will enter a position and the number to be displayed. For example, we want to display the position 3. 30 is at position 3. For option 10, the list will only be displayed. Thank you.